This video, I'm going to be working through a grade 9 maths test for term 1. I'm going to be working through all the questions step by step, so hopefully it makes sense, helps you revise, but let me know in the comments if you do have any other questions. Let's get straight into it. So, question 1, calculate the following without the use of a calculator, show all your steps. This question, they're testing, do we know BODMAS, do we know how to work with negative numbers, difference changing signs, do we know our squares, our cubes, our square roots, and our cube roots? Let's get into it. Question 1.1. We've got 18, take away 10, add 4, minus 6. This is a straightforward one. You'll find often the first question is quite straightforward. It gets you a bit more confident for the rest of the paper. So this one, it doesn't matter which order we do it. So if you look at BODMAS, addition and subtraction, they together at the end. Doesn't matter which order you do it in. All that matters is you get the right sign. So I'm just going to start at the front here. 18 take away 10, that gives me 8. Add the 4, take away the 6. Let's see what we can work on next. 8 add 4, let's see, that's 12. Take away the 6. And 12 take away 6, it's just going to give me 6. So that is our final answer there. 1.2 is they are testing if we know what to do with negative signs. So we've got 24 take away negative 18. So they're just trying to check us with these negative signs. A minus and a minus when it's like this becomes a plus. So we've got 24 add 18. Sorry, negative 24. I forgot that negative. Okay, so that's a common thing when you're copying questions like this. So it's a good reminder to us all. Negative 24 add 18. So you can do this on a number line. It is without the use of a calculator, but you should be able to just figure this one out. So you can do it on a number line, go from negative 24 and count 18 jumps. Or what I would usually do is just work out the difference. So the difference between 18 and 24 is 6. So this answer is going to be minus 6. Question 1.3. Is testing if we know what to do with negative signs when we're multiplying them. So let's get this one written out. 1.3. We have got 8 times negative 3 divided by negative 6. With a question like this, we've only got timesing and dividing. So it doesn't matter what order it is. We don't really have to worry about BODMAS here. What I would do is just start with this first one. So 8 times negative 3. So a positive times a negative is going to give us a negative. 8 times 3 is 24. And then this part stays exactly the same, divided by negative 6. And then a negative and a negative. So negative 24 divided by negative 6 is going to give us positive. And 24 divided by 6 is 6, 12, 18, 24. So that's 4. Okay, and then as you know, with these signs, it's not wrong to include the positive, but we don't need to include that positive there. Let's go on to 1.4. We've got minus 4 squared plus minus 4 cubed. Again, they're just checking we know what to do with these negative signs. So if we work out 4 squared is 16. this negative sign is not in a bracket, so we're not squaring the negative sign. So it's still going to be minus 4 squared is 16. So it's going to be minus 16. Add on. This is the same as saying minus 4 times minus 4 times minus 4. Okay, so minus 16. Add on, let's see. Minus 4 times minus 4, let's just do this in parts. So minus 4 times minus 4 is going to be positive 16. Times by minus 4. Minus 16. This is going to be positive 16 times negative 4. So 16 times 4 is 64. And a positive and a negative makes a negative. It's going to be minus 64. And so this one becomes negative 16. Positive and a negative makes negative. So minus 16 minus 64. Which is going to give us negative 64 add 16. So 64 add 6 is 70. Add 10 is 80. So negative 80 for this one. 1.5. Take away the cube root of negative 0.064. Okay, so the square root of 169, you should just know this one. That is 13. You should know that. If you don't know that, if you don't know what it is, what I would recommend is if you come across a question like this you don't know, I would start testing. So I would say like, I know 10 times 10 is 100. Okay, so it's not that. 11 times 11 is 120, 121. So it's not that. I know I'd start testing like this, 12 times 12, and then eventually you're going to get 13 times 13. So that's if you're really stuck in the test, you're going to do it like that. And you're going to get 13 times 13 is 169. Okay, so that is pretty straightforward. That's what we get there. And then they're trying to trick us a little bit here, trying to make it a bit more tricky. Take away the cube root of 0.064. Okay, so in this previous question, we saw 4 cube. We worked this out. So we said 4 cube is 64. So they've done this to help us a little bit. So we know it has to be something to do with 4 here. So if we have the cube root of a negative number, it's still going to be a negative. So we know it's going to be negative something. Let's just have a look at what this could be. So if I had, say, 0.4 times 0.4 times 0.4, that would be 4 times 4 times 4 would be 64. So that is right, but now it's not. We need to check how many zeros we need, how many decimals we need. So if I'm multiplying 4 numbers like this, well, sorry, 3 numbers like this, I've got 1 decimal place, 1 decimal place, 1 decimal place, 3 decimal places. That means in my answer, I'm going to need 3 decimal places. So 0.03 decimal places. Okay, so that is actually what we need. So this number here is 0.4. So I kind of just happened to fall on this. I did try when I was working this out before, I was also trying to work out maybe it's 0.004 or maybe it's 0.04. The only tricky thing with this is you're just trying to play around so that you get the right number of decimal places. So if I have this where it's 0.4, 0.4, 0.4, then it's 3 decimal places, which gives me the 3 decimal places when I multiply. Okay, so we can keep going then. I just erase this part here. Okay, so then we've got 13 minus 0.4. A minus and a minus makes a plus, so this is going to be 13 add 0.4, which is just going to be 13.4. Okay, so the square root of 1 and 9 over 16 times 1 and 2 over 3 divided by 9.3 recurring. Okay, this first one is pretty straightforward. So we can say the cube root of 1, the square root of 1 is just 1. Then the square root of 9 is 3. And the square root of 16 is 4. So that's pretty easy to simplify. Times by 1 and 2 over 3 divided by 9.3 recurring. Okay, if we are going to work these fractions out, I would convert them to improper fractions first. So I go 1 times 4 is 4, add 3 is 7, so 7 quarters, times this one, if we convert it to an improper fraction, 1 times 3 is 3, add the 2 is 5, 5 over 3, and still divided by that 9.3 recurring. When we multiply fractions, it's really straightforward. We just go top times top, bottom times bottom. So we're going to get 7 times 5 is 30, and 4 times 3 is 12, divided by 9 and 3 recurring. And then that's all we've got to do is just work out this part then. Dealing with this number here with the recurring decimal, so we need to convert it into a fraction so that we can work out this division part. If we look at this recurring decimal, how we would do that is I'm going to just focus on this part, so this 0.33333. And what we say is, we say that x equal 0.333 recurring. Then that means 10x is 10 times that. So 10x is going to be 10 times that. If we shift the decimal like that, it's going to be 3.33 recurring. Then we say 10x take away x is going to be 3.333 take away 0.333. Then 10x take away x is 9x is equal 3.333 take away 0.333. All we're going to be left with is the 3. So x is equal to 3 over 9, which you can simplify and say that is 1 over 3. You just divide both the top and the bottom by 3. So we can simplify and we say now with this recurring fraction, that's 1/3. So actually we can rewrite this part and say 9 and 1/3 because we didn't do anything with that whole number. So 9 and 1/3. So then our division starts to look like this. So we've got 30 over 12 divided by 9 and 1/3. Again, it's not great working with improper fraction here, whole number here, so I would convert this one into an improper fraction. Okay, so again, we go 9, so the big number times the bottom number. 9 times 3 is 27. Add the top number is 28. 28 over 3. So then we can say 30 over 12 divided by 28 over 3. When we are dividing with fractions, we do the KFC method. So we keep the first term, we flip the second term, and we change the sign. Because multiplying fractions is really straightforward. So now we're going to have 30 times 3. Okay, so 30 times 3 is 90. And 12 times 28. Now that's a bit of a tricky one to do without a calculator. So let's just work it out. So 28 and 12. Okay, so 2 times 8 is 16. 2 times 2 is 4. 1 times 8 is 8. 1 times 2 is 2. That's going to be 6, 12, 13, and 3. So it's going to be 90 over 336. Okay, so this is our answer for this one. Let's just see how many marks. I think this one we can also simplify. Okay, it is a 4-mark question. We can simplify this then. So I would then, it's best practice, just always simplify it. I would say both of these we could probably divide by 3. So let's say 90 divided by 3 is 30. And then 336 divided by 3, quickly work this out. So 3 into 3 goes once, 3 into 3 goes once, 3 into 6 goes twice. So get 112. I reckon we can divide that by 3 again, potentially. Let's just get some space here. Let's see, 112, let's divide it by 3 quickly and just see. Can 3 go into 1? No. Can it go into 11? Yeah, it goes in there 3 times remainder 2. Okay, so it actually doesn't go into 3. So then your next step would be, I would divide them both by 2. Okay, so 30 divided by 2 is 15. 112 divided by 2 is going to be 56. And I think that is as far as we can go for this one. That is our final answer for this one. Okay, so quite a main question. They're asking a lot of you there. So you had to, first of all, convert to mixed fractions. Mixed. Convert, rather, not mixed fractions, improper fractions. Okay, so convert from these mixed numbers, convert them to improper fractions. Then multiply. Okay, the multiplying was pretty straightforward. Then we had to convert the recurring decimal to a fraction. And then finally, well, not finally, once we had it as a fraction, we again converted it to an improper fraction. And then did keep, flip, change to divide. And once we got our answer, we had to simplify our fraction as far as we could. Okay, so a little bit of a mean question. It's 4 marks, so you can see it was quite easy to get these, even if you couldn't do, say, the recurring decimal, you should have got some marks already just for converting it to an improper fraction and multiplying it. So just try to keep a cool head, take it step by step, especially in a question like this. Okay, question 2. Simplify the following and give your answers as positive exponents. Okay, so we're getting into all of our exponent laws. These are the laws, you have to know these. They're going to come up again and again. So let's have a look at these ones. Okay, 2.1.1. We got minus 4 x to the power of 3 power of 0. Okay, so the first thing we are doing here is we are using this part here. The exponent law is anything to the power of 0 is 1. So this part here, anything to the power of 0 is 1. So it's just going to be 1 minus 4 times 1. So again, this one is a really straightforward one to get us started. Minus 4 times 1 is minus 4. Okay, so this one, we had to know anything to the power of 0 is 1. That's our law for this one. 2.1.2. We have minus 4 x to the 3 to the power of 0. Again, they're just checking you know this law. So anything to the power of 0 is 1. So this whole thing is to the power of 0. So this whole thing, the answer is just 1. 2.1.3. We've got 3 to the power of minus 1. A squared b minus 5. We have to simplify and give our answers as positive exponents. Okay, this one, we can't do too much. 3 to the minus 1, a squared, b5. We can't really simplify this one at all. What we can do is we can write it with positive exponents. So what they mean is this and this, it's got negative exponents. We want it positive. So how we're going to write it is we keep the a squared at the top. If you want it to be a positive exponent, you take these ones down. So it's going to be 3 to the minus 1. If you take it down, it's going to be 3 to the 1, b to the 5. And you don't really even have to write that 3 to the 1 like that. You can just say a squared over 3b5. There's no reason for you to write that one. Okay, so this one wasn't much simplifying to do. What they were checking you for here is, do you know how to write it with positive exponents? And so it's just to say a to the minus 1, you can write this as 1 over a to the positive 1. That's the law we used for that one. Two point 1.4. We have got minus 2y squared minus 2y minus 2. Okay. So what we can do for this one, first of all, is we're going to leave the first term as it is. So minus 2y squared. This one, I'm going to get this exponent, I'm going to put it in here with these. So it's going to be minus 2 to the power of minus 2, y to the power of minus 2. And then what I would probably do is I would take this down, how we get it to positive exponents. So I would say minus 2y squared over this bracket here. So it's going to be minus 2 squared y squared. Because when we take these exponents down, they become positive. Let's see if we can do anything here. So the minus and the minus are going to cancel. And this is going to be 2y squared over 2 squared is 4 over 4y squared. We can simplify, so 2 and 4 we can simplify. So it's going to be 1y squared over 2y squared. That's going to cancel. So the y squares are going to cancel each other. And so we are actually just left with, in this one, we are left with a half. Okay, so the laws we used for this one is we had to multiply the exponent in and put it on both the 2 and on the y. And then we use the positive exponent laws. So when we take it down, it becomes a positive exponent. 2.1.5. X to the 4, y to the 3, over x to the 5, y to the 3. Okay, the law they want us to use here is if we are dividing numbers like this, so if we have xa over xb, what we can do is write it together and say that's xa minus b. So it's the top exponent minus the bottom exponent. So in this case, we're going to have x4 minus 5, y3 minus 3. So that is going to be 4 minus 5 is minus 1. Y is 3 minus 3, so that's 0. Okay, so that is going to give us x minus 1. Y to the power of 0, anything to the power of 0 becomes 1. So that's just times 1, which we don't really need. We can just say x to the minus 1. And they say give your answer as a positive exponent. So instead of x to the minus 1, we are going to say 1 over x. So the 1, or just 1 over x. Okay, and then 2.2, calculate the following without the use of a calculator. Show all your work. We have got 4 times to the power of minus 2 times 6 squared times 3 to the minus 2. Okay, I would start by putting these as positive exponents first. So this 4 to the minus 2 squared, I would rewrite that as 1 over 4 squared times 6 squared. So 6 squared we can rewrite as 36. 6 times 6 is 36. And this one I would rewrite as 1 over 3 squared. Then 1 over 4 squared. So 1 over 4 times 4 is 16 times 36 times 1 over 3 times 3 is 9. And then it's just a case of multiplying this out. So if it's easier, you can write it as 36 over 1. And then we just multiply all these fractions. So 1 times 36 is 36 times 1 is 36. And at the bottom, we've got 16 times 1 is 16 times 9. Let's work that out. So 9 times 6, 9, 18, 24, no, 9, 18, 27, 36, 45, 54. Nine times 1 is 90. This is going to be 5 and 9, 14. So 144. So we can have 36 over 144. And then whenever we get a fraction, make sure you simplify it as far as you can. So I would divide both of these. 36 can divide by 12, and 144 we can divide by 12. So that's what I would be dividing by. So 36 divided by 12 is 3. 144 divided by 12 is 12. And then again, we can divide them both by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. And so that is our final answer here, 1/4. We've got a whole lot of exponent questions. It's a bit of a mix between algebra and exponents. So we're trying to solve for x using these exponent laws. So 2.3.1, 3 to the x is equal to 81. With a question like this, the only way you can solve for x is if you get the bases the same. So if this side is 3 to the x, we want the other side to also be 3 to something. So this, we want to try and convert it into 3 to something. This one, it took me a while to figure this one out, but if you go, we know we want the side to be 3. So it's going to be 3x is equal to something. If you go 3 times 3 times 3 times 3, it gives you 81. So that means 3 to the power of 4 gives you 81. As soon as you get them like this where the bases are the same, then you can say, well, the base is the same. The base is the same. So that means the exponents have to be the same. So x is then equal to 4. So it's really straightforward once you get to that point. 2.3.2. We have 5 to the power of x is equal to 1 over 25. This is exactly the same as the previous question. They want us to make sure that we get the bases the same. So in this case, we have at the base here, we've got a base of 5. So we want on this side a base of 5. So my first step would be converting this 25. So I would say 25 is the same as 5 squared. Okay, which is good, but we don't want it at the bottom of the fraction here. But we can use our exponent laws and then say 5 to the x is equal to, if I take this 5 squared up, it becomes 5 to the minus 2. So that's one of my exponent laws. If it's at the bottom like this, if I take it up, it's fine to take it up. It just becomes a negative exponent. And then again, we have got the bases are the same here. So this is 5, which is the same as this. And so that means the tops are the same. The exponents are the same. So x is then equal to minus 2 for this one. Two point three point three. 2 to the power of x plus 4 is equal to 1. Exactly the same thing. We're trying to get the bases the same. So in this case, we want both sides to have a base of 2. This one, what they want you to see is that we can use one of the exponent laws. So if you have ax plus y, you can rewrite that as ax times ay. Okay, so that's what they're wanting us to do here. So that means we can do that for that 2 there. So we can say 2x plus 4, or we could say 2 to the x times 2 to the 4 is equal to 1. We can then take this 2 to the 4 across. We were timesing by it on the side. When we take it across, we're going to divide. So we're going to get 2 to the x is equal to 1 over 2 to the 4. And then this is very similar to the previous question. We can then say, well, I want it to have the same base, so I'm going to take this up to the top. So it's going to be 2 to the x is equal to 1. No, sorry, not equal to 1. We're taking it up. 2 to the x is equal to 2 to the negative 4. When I take this exponent up, it becomes negative 4. And then our bases are the same. We've got a 2 here and a 2 here. And so we can say x is equal to negative 4. So a little bit trickier. There was one extra step in this one. But all of these exponent equations, you're just trying to get the bases the same. Okay, and then question 2.4. Let me just get some space for it. Question 2.4 is they want us to calculate the following and then give our answer in scientific notation. Okay, so let's see. Okay, so we have got 2.5 times 10 to the negative 6 times 6 times 10 to the 10, add 5.7 times 10 to the 8. Okay, so what I would do first of all is we are multiplying these two terms, so I would try sort these ones out, simplify a bit. So 2.5 times 6, we can work with these terms first. So 2.5 times 6, it's multiplying, so it doesn't matter which order we do it. So 2.5, then it would be 5, 7.5, 10, 12.5, 15. Okay, so that's going to be 15. If you need to, you can just work it out like 2.5 times 6. 6 times 5 is 30. 6 times 2 is 12. So this is going to be 15. Okay, so that's how we work that one out. So we get that part is 15. If we work out these tens, then we've got 10 to the negative 6 times 10 to the 10. So that is going to be times 10. So negative 6 times 10 to the 10, we can just add these exponents. So negative 6 add 10 is going to be 4. And then we've still got this end part. So plus 5.7 times 10 to the 8. Then you have two options then for how you want to work this out. So you can either, we're trying to add these. So if we're trying to add them, we need to make sure that these have the same exponents. Otherwise, we can't add them. So you can either convert one of them to 10 to the 4 or to 10 to the 8, or you can write them out fully and add them. So that's what I'm going to do, but whatever works for you. So I'm going to say 5.7 times 10 to the 8, so that's going to be 5, 7, 1, 2, 3, 4, 5, 6, 7. Okay, let's just check ourselves. That is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so that's times 10 to the 8. And then the next one we're going to add is this 15 times 10 to the 4. So that is going to be 1, 2, 3, 4, 15. Let's see, 1, 2, 3, 4. Yep, that's right. So it's going to be like this. We can add these 0, 0, 0, 0, 5, 1, 0, 7, 5. Okay, it's a really big number. And then that is our final answer, but they want us to give it in scientific notation. So we just need to go back in. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So our answer is going to be 5.7015 times 10 to the 8. Okay, a little bit of a tricky one. They wanted to make sure they're tricking you a bit here. They're trying to see, are you going to add, are you going to subtract? What are you going to do? We've got some financial maths and some speed, distance, time questions. So 3.1. You receive 2,500 Rand from your grandfather on your birthday. You decide to invest the money in the bank for your studies 4 years from now. The bank gives you the following two options. So option A is we've got compound interest, and option B is simple interest. Decide which one will generate more money in the given period. Okay, so let's have a look at option A. So option A is compound interest. So we're going to use this formula, which you need to know these formulas off by heart. This is our compound interest formula. They tell us here our principal amount, so the starting amount that we get given from our grandfather is 2,500 Rand. Our interest rate for this one, this option is 8%. We always use it as 0.08, so we always divide it by 100 because it is a percentage. And our euros, number of years for this one is 4 years. Okay, so now it's just a matter of subbing in these values. Okay, so we're going to say A is equal, our final amount is equal to 2,500 times 1 minus 0.08 to the power of 4 years. Okay, we're going to put this into the calculator and see what we get for our final value. So 2,500 1 minus 0.08, and this is all then to the power of 4. Okay, sorry, we should not be subtracting here. This one we are adding interest, so just be careful. That's a good one to check. This one you are earning interest, so you're going to be adding on here rather. Sorry about that. So we should be adding on here. We are earning interest. So this one, our final amount is going to be 3,401.22. Okay, so that's option A. Let's have a look then at option B. Okay, so option B, it's again, the principal amount that we're starting with is 2,500 Rand. The number of years, again, is 4 years. This time it is simple interest, and the rate is 7.5%. Or we could say 0.075. Okay, let's work it out. Our simple interest formula is the principal amount, 1 add, because we're working out interest times the number of years. Okay, if we put in the values 2,500, 1 plus I is 0.075 times 4 years. Let's put it into the calculator. So we're going to have 2,500, 1 plus 0.075 times And it gives us 3,250 Rand. Okay, and they say decide which one will generate more money in the given period. Okay, so this one, option B was 3,250. Option A was 3,401 Rand. And so option A will generate more interest. So our answer is option A, which we kind of knew because compound interest generally is better than simple. Because it leaves you, sorry, versus B, 3,250. Okay, then let's look at question 3.2. Calculate the percentage increase if the price of diesel increases from, okay, so it goes from 11 Rand 21, increases to 12 Rand 30. Okay, round your answer off to 2 decimal places. Okay, so for percentage increase, you should know this formula just straight away. You need to work out what is the difference in the price, what was the initial price, and then you times it by 100. That will give you your percentage increase. Okay, so let's first of all work out the difference. So difference is 12 Rand 30 minus 11.21. 10 take away 1 is 9, 2 take away 2 is 0, 2 take away 1 is 1, 1 take 1 is 0. Okay, so that's our difference, is 1 Rand and 9 cents. So we can then work it out. So percentage increase is the difference, so 1 Rand and 9 cents, divided by the initial 11 Rand 21 times 100. Let's put that into our calculator. So we got 1 Rand and 9 cents divided by 11 Rand 21 times it by 100 gives us 9.7234. Carries on. We want 2 decimal places, so 9.72%. Okay, just make sure you include that percentage sign because it is percentage increase that they're asking for, so they want to see that percentage sign. Okay, and then question 3.3 is a speed, distance, time question. So again, this is something that you have to know the formula for. So we need to remember that speed is equal to distance divided by time. Okay, in this case, they tell us the speed (0.9 times 10 to the 3). And they tell us the time, 24 hours. Number, so I'm going to take it out of scientific notation. So 0.9 times 10 to the 3. That means we're going to have 1, 2, 3. Yeah, that's right. 1, 2, 3. Yeah, that is 900 kilometers per hour. Okay, and then it's just a case of putting it into this equation. So our speed is 900. Distance is what we're trying to work out. And our time is 24 hours. So when we take this across, we were dividing by 24. Now we're going to times it by 24. So it's going to be 900 times 24 is my distance. Let's work that out then. 4 times 0 is 0, 4 times 0 is 0. 4 times 9 is 9, 18, 27, 36. 2 times 0 is nothing, 2 times 0, and then it's 3 zeros. 2 times 9 is 18. 3 and 8 is 11. Okay, so that is my total distance. 21,600 kilometers. And then they want it in scientific notation, which means we want a decimal place there. So it's going to be 2.16 times 10 to the 1, 2, 3, 4 kilometers. That is how far was traveled. So they say simplify these. 4.1.1. We have negative x, 5x plus 1. Okay, so they are testing if we can multiply into brackets correctly, and they want to make sure we can multiply this minus sign. So we're going to go negative x times 5x. So that is going to be negative 5x squared. And then negative x times 1 is going to be negative x. We can't simplify any further than that, so that is our final answer for this one. Four point 1.2, we've got negative 2, 3x plus y times 5x minus 4y. Okay, so we are multiplying, so it doesn't matter which order we do this in. I'm going to multiply this negative 2 in first. So we're going to go minus 2 times 3x. That's going to be negative 6x. Minus 2 times y is minus 2y. And then we still have to multiply this bracket here. Okay, so we can go, let's get a different color. This one we've got to do what we call FOIL. So first, then outer, then inner, then last. Okay, so we're going to do our first terms. So minus 6x times 5x. So that's going to be minus 30x squared. Then we do what we call the outer terms. So we're going to go minus 6x times minus 4y. So minus 6 times minus 4 is going to be positive 24xy. Then we do our inner terms. So our inner terms is going to be minus 2y times 5x. So that's going to be a minus and a positive makes negative. 2 times 5 is 10xy. And then finally, we are doing the last terms. So it's going to be minus 2y and minus 4y. So minus 2 times minus 4 gives us positive 8. y times y is y squared. And then we can simplify a bit further. We can do these middle terms a bit more. So we're going to get minus 30 x squared. Can't do anything with that. 24xy minus 10xy is going to give us 14xy. Add 8y squared. And that is as far as we can go in simplifying that one. Okay, 4.1.3 is the same thing. We just got to try with fractions now. Okay, so we've got 2x plus 1 over 4 minus x plus 2 over 2 minus 1 over 4. Okay, so fractions, whether it's got algebra in it or not, you can't add and subtract unless the base is the same, the denominator. So in this case, we have got 2 with 4s in the bottom, so that's fine. This one in the middle here, we need to convert it to something over 4. So we're going to find an equivalent fraction for this one. So what we can do is we can say we want the bottom to be, so x plus 2 over 2. We want it to be something over 4. With fractions, it's always just what do you do to the bottom. So in this case, we go 2 times 2 gives me 4. At the top, we're going to do the same thing. So it's going to be 2 times the x plus 2. Okay, so we can rewrite this equation as 2x plus 1 over 4 minus 2x plus 2 over 4 minus a quarter. Now the bases are all the same, so we can actually then rewrite this as just everything on the top. So 2x plus 1 minus 2 times x plus 2 minus 1 over 4. We can put them all into one fraction like this. Then we need to multiply this bracket out. So we're going to get 2x plus 1. This bracket is going to be minus 2 times x. It's going to be minus 2x. Minus 2 times 2 is going to be minus 4. And then minus 1 over 4. We simplify here, so this is going to be 2x minus 2x, so we're actually getting rid of those. They're going to cancel. 1 and the minus 1, they'll cancel. So this is going to be negative 4 at the top over 4. And then minus 4 divided by 4 is going to be minus 1 as our final answer there. Okay, 4.2, they're asking us now to solve for x. So 4.2.1, we have got 3x minus 1 is equal to 5. Okay, when we're solving for x, we're just essentially trying to get x all by itself. So I would take this across first, minus 1. When we take it across, it's going to be add 1. So 3x is equal to 5, add 1. You always do the opposite thing when you take it across, which means we're going to have 3x is equal to 5 add 1 is 6. Then I want to get rid of this 3. It was timesing by 3. When I take it across, I'm going to divide it by 3. So I'm going to say x is equal to 6 divided by 3, which is 2. Okay, so that is our final answer. X is equal to 2. (4.2.2). It's a longer one, but it's the same principle. Let's work it out. We've got negative 6 times x minus 3 is equal to 2. X add 7 minus 5, x minus 2. Okay, so first things, we've got to get rid of these brackets. So it's going to be minus 6 times x, negative 6x. Minus 6 times minus 3 is positive 18. This side, 2 times x is 2x. 2 times 7 is 14. Minus 5 times x is minus 5x. Minus 5 times minus 2 is positive 10. Then we want to try get all the x's on one side, all the numbers on the other side. So let's try get all the x's on the right, all the numbers on the left. So, and on this side I've got 18. If I take across positive 14, I take it across, it's going to be minus 14. And if I take it across positive 10, it's going to be minus 10. On the other side, I've got 2x minus 5x. And then I'm going to take this negative 6x across, it becomes positive 6x. Okay, I'm just trying to get numbers on one side, x's on the other side. So in this case, I'm going to have 18 take away 14 is 4. 4 take away 10 is negative 6. And here 2x take away 5x is negative 3x. Add 6x is just positive 3x. Again, I want x by itself. I'm going to get rid of this 3. I was timesing by 3. I'm going to take it across, divide by 3. So minus 6 divided by 3 is equal to minus 2, which is equal to x. So in this case, x is equal to minus 2. So it's a little bit longer. Stay testing. Make sure you can multiply out and then simplify. But it's all steps you've done in the questions. Okay, so we've got 3 figures here. It says 5.1, draw the next figure in the pattern. Okay, so we can see each time they're just adding one of these things. So figure 4 is going to be okay, so it's just exactly what we had before with one extra of these shapes. Then 5.2, consider the following table and write down the values of A and B. Okay, so we can see in the first figure, there are 8 matches. In the second figure, there's 15 matches. Third figure, there's 22 matches. In the fourth figure, how many matches are there? We can count this figure that we have just done. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, so that value there, A is 29 matches. And then we need to work out the number of matches if it's figure 10. So what I would say is I'm going to work out 5.3 first, so we can work out a general formula, and then we know how to work out 10. Okay, so how we work this out is we are going to have a look here at these. We're just going to look at the number of matches, and we're going to see how many matches do we add on each time. So 8 to 15, that is add on 7. So again, add on 7. And again, add on 7. Okay, so when it's like that, when you add on 7 every time, then you're going to go Tn is equal to 7n. And then in this case, we've just got to check. So if I said the first figure is equal to 7 times 1, that would give me 7. And I would have to add another one to get the 8. And let's just check again. Term 2, the figure 2, we're going to go 7 times 2 is 14. add 1 will give me 15. So we can see this is my general formula. So it's always 7n, and then we add. If we want to then find the 10th figure, we're going to go, the 10th figure is 7 times 10, add 1. So 7 times 10 is 70, add 1 is 71 matches. So this one here, our answer is going to be 71. 5.3, the formula for the nth term, this is our formula. Question 5.4. Okay, let's just write down our formula here. So we said it is 7n, because that's the difference, is 7 every time. Add 1. So which figure will consist of 50 matches? So they want to know which one is going to have 50 matches, which number. So we're going to work out what is the n value, which number, which figure number. So I was adding 1, I'm going to take it across and subtract 1. So 50 minus 1 is equal to 7n. 50 minus 1 is 49. I was timesing by 7. I'm going to take it across and divide by 7. So 49 divided by 7 is equal to n. 49 divided by 7 is 7. So we know the 7th figure has 50 matches. For that one, we've got our general formula. They're just checking that you can work backwards then. And then next up, we have our formula Tn 7n add 1. They say how many matches will be needed to make the 25th figure. So we want to know how many matches will be needed for the 25th. So we're going to go 7 times 25, add 1. Okay, so you can work out this 7 times 25 however you want. I'm just going to do it like this. 7 times 5 is 35. 7 times 2 is 14. That's 5, 7, so 175. 175, add 1, so it's going to be 176. So, how many matches will be needed to make the 25th figure? We need 176 matches. The relationship between x and y is represented by y is equal to a half times x, add 1. And they want us to determine some missing values in here. Okay, so we're just going to be subbing values into this equation and then working back. So let's first of all find m. So m is when, we can see here, m is when y is equal to 1. So we are just going to sub this into the equation and work out what m would be. So 1 is equal to a half x add 1. Let's solve for x. So this one we can take across. We were adding 1. When we take it across, we're going to subtract 1. So 1 minus 1 is equal to a half x. 1 take away 1 is 0. 0 is equal to a half x. We want this half gone, so we were timesing by half. We're going to take it across, divide. 0 divided by half is 0. So x is equal to 0. So we can say m is 0. So in this one here, m is 0. Okay, let's see. Next, we've got to work out p. So when x is 2, what is y? Okay, so the value p, we know that x is 2. So y is equal to a half x plus 1. Y is equal to a half. X is 2 plus 1. A half times 2 is 1. And we've got to add 1. And so it's 2. So we say P is 2. So when x is 2, then y is 2. Okay, and then finally we are supposed to find n when y is 26. Okay, so n y is 26. So you can say 26 is equal to a half x plus 1. We're going to take the 1 across. We want to get rid of that, so we're going to subtract 1. So 26 minus 1 is equal to a half x. So that's going to be 25 is equal to a half x. We want x by itself. We're going to get rid of this half. We were timesing. When we take it across, we're going to divide. So 25 divided by a half is equal to x. If we're dividing, we go 25 times 2 over 1 is equal to x. That is going to be 50 is equal to x. So in this case, n is 50. So when x is 50, then y is 26. So this one is just, they give you an equation and you just got to substitute values in, either the x value you sub in or the